Hello everyone, this is Ashraf from Sri Venkateswara College of Engineering, pursuing my studies in computer science engineering. Okay, today I'm doing a video assignment on the corrosion, and today's subject is applied chemistry for CSE stream. Topic is corrosion prevention methods. Okay, first, what is corrosion? Corrosion can be defined as the destruction or deterioration or the loss of metals or alloys by surrounding environment through chemical or electrochemical reaction. Here you can see a process of where the oxygen is is combined with one second. Okay, the oxygen is uh, in the presence of oxygen, the iron is forming a rust in the presence of oxygen and water. It form Fe2O3 H2O, which is called as corrosion. Types of corrosion and prevention control methods. Corrosion can be controlled by preventing the formation of galvanic cells on surface metals. The methods to control corrosion can be classified as design and selection of materials, protective coating, and inorganic coating, metal coatings. Cathodic protection. Protection coating. Corrosion is prevented by the application of protective coating on the surface of metal. Thereby, the metal surface is isolated from the corrosive environment. So, we can now see about important types of protective coating. Metal coating. Okay, the first is metal coating. Inorganic coating. Now we can go deep into the metal coating. The metal coating is a process of coating base metal with a layer of protective metal. It is known as metal coating. There are two types of metal coating. First is anodic coating and second one is cathodic coating. Basically, anodic coating is a coating of anodic to base metal is called as anodic coating. The best example is galvanization. Let us see about galvanization. Process of coating zinc on the base metals or base metal can be iron or steel surface by or dipping is known as galvanization. The galvanization process is carried out as follows. The metal surface is washed with organic solvents by CCl4 toluene and benzene to remove organic matters. The metal surface is treated with dilute H2SO4 to remove rust and other deposits. Then it is well washed with water and it is air dried by passing with hot air. So the metal is treated with a mixture of zinc chloride and ammonium chloride. The solution which prevents oxidation of coated metal. Then the metal is dipped into the molten zinc at around 4500 degrees Celsius and excess of zinc on surface is removed by passing a pair of hot rollers which remove the excess of zinc and produces thin coating. You can see the process of galvanization in this picture. First, the cascotic is cleaning and the process of rinsing is taken and pickling, rinsing, flux solution, drying, zinc, bath, and cooling. So this all process is known as galvanization process. Inorganic coating. This coating are produced at the surface of metal by chemical or electrochemical reaction, anodizing and phosphoryl. Anodizing. First, anodizing. Anodizing coating are generally produced on non-ferrous metals like aluminum, zinc, and their alloys by anodic oxidation process in which the base metal is made as anode. Anodization of aluminum. When aluminum metal is made to anodic in an electrolytic path with H2SO4 or chromic acid as an electrolyte, a thin layer of aluminum oxide is formed on the surface. This process is called anodizing or anodic reaction. The porous coating is obtained by anodic oxidation. It is carried out by making it anode and add to the bath. And when a current of moderate density is passed, the oxygen liberated at the anode combines with it to form oxide, which takes the form of thick film Al2O3, which is aluminum oxide deposits on the surface of the object. So aluminum oxide gets hydrated to aluminum oxide. The coating is slightly porous and its seal is covered dipping in hot water. Aluminum oxide gets hydrated to Al2O3. H2O, which occupies more volume and hence protects the metal from corrosion. This is the deep picture of the process. In the place of anode reaction, aluminum is added with H2O, which is known as water, to form Al2O3, which is aluminum oxide. It's liberation of 6H plus ions. Cathodic reaction, 6H plus ions with 6 electron don't pair electrons to form 3H2, which is 3 hydrogen molecules. Overall reaction, we get aluminum plus water give aluminum oxide plus 3 water. So this is anodic reaction and this is cathodic reaction where it takes place. Now, this you can see the porous layer, which is the formation of the process. Aluminum will be in the porous layer. Aggregate products will pore once and dissolution of pore walls, and then porous filled with hydrated aluminum gel. This is hydrated aluminum gel. Surface layer is ciliar polymer may appear thickness. It becomes thick. Next, cathodic protection. Now we are going moving into the topic called as cathodic protection. In Catholic protection, it is a technique of offering protection to a specimen against corrosion by providing electrons from an external source. There are two important methods of cathodic protection: sacrificial anode method and impulse current voltage method. Now, sacrificial anode method. Sacrificial anode method is nothing but a metal which is anodic to the specimen method where the metallic structure to be protected is connected to a more anode metal is known as using a metallic wire is known as sacrificial anode method. Now, the examples are when a steel metal to be protected, it may be connected to a block of magnesium or zinc. In such cases, steel acts as a cathode and is unaffected. Magnesium or zinc act as an anode and undergo sacrificial corrosion. Now, you can see the picture where the sacrificial anode method is going taken place. That it is an electrical conductor. This is an anode. It is magnesium block, and this is a steel pipe where it is known as cathode. It is connected where the zinc is transferred, or the coating is done, or the corrosion is transferred. Inverse current method. In this method, the the, um, the method the current is used and the solutions are used to change the corroded metal or corroded material into their original form. Here, DC, the inward current method, the metal to be protected is connected to the negative terminal of the external DC supply, and the connected inward electrodes such as graphite under this condition, the metal acts as a cathode and hence does not undergo corrosion. The inert electrode acts as an anode, but it does not undergo corrosion because it is inert. You can see the diagram where it is taken place, reverse current method. And thank you. This was the topic given to me, and thank you for liking my video. Do comment, do share. Thank you.